here's the problem that I posed. For an object fired up into the air with an initial velocity, what is the sign of the object's acceleration on the way up and on the way down? So up is positive in this problem. So the question was, on the way up, is the acceleration positive and negative on the way down? Or is it B, on the way up it's negative, positive on the way down? Or is it C, negative on the way up and on the way down, or positive on the way up and positive on the way down? Okay, so let's consider this problem. Let's go down here. So we will imagine an object on the ground here, and it gets fired up in the air. And I'm going to give it an initial velocity at t equals 0 of 19.6 meters per second. So that's the velocity it gets fired up at. So we know that as it goes up, it's going to slow down because gravity is going to be pulling it down. So and that the rate of that is going to be 9.8 meters per second squared. So what does that mean? That means that every second its speed will be 9.8 meters per second slower than it was a second before. Okay, so at time 0, the speed is 19.8 meters per second. So a second later, at t equals 1, the velocity will be 9.8 less that, which is actually 9.8. And now his velocity will be less at 9.8. And at t equals 2 seconds, it will travel up like this. And when it gets to here, actually, the velocity will become 0 meters per second. Okay, now let's look. So it was 19.8 meters per second. A second later, 9.8 meters per second later. A second later, it's 9.8 meters less than that per second, which is 0. So it stops at the top. And then what happens? It starts to come down, doesn't it? So it comes down now. And now at t is equal to 3 seconds, its velocity will be minus 9.8 meters per second. And at t equals 4 seconds, its velocity will be, it's now getting faster, increasing its magnitude, and it will be at minus 19.6 meters per second now when t is equal to 4. So so the magnitude decreases and then the magnitude increases as it comes down here. So if we were to look at those numbers and just say, okay, it starts off at 19.6, then it becomes a second later 9.8, second later it becomes 0, and then a second later it's minus 9.8, second later it's minus 19.6, and so on. So all the time it's becoming more and more negative, the velocity is becoming more negative. So in other words, the acceleration is negative on the way up and it's also negative on the way down, even though the magnitudes might be getting smaller. And here the magnitude might be getting bigger, but the actual acceleration is negative all the way. So the answer is C. It's negative on the way up and it's negative on the way down. And that makes sense because this is acceleration. G is acceleration due to gravity and due to gravity. So it's completely independent of whether it's going up. It doesn't say it has a different acceleration depending on its motion. It doesn't care. Gravity doesn't care whether the object is moving up or moving down. The acceleration is due to gravity, not due to motion. So it's not going to be different depending on what type of motion it has, whether it's going up or down. So that's the answer. The answer is C. It's negative on the way up and it stays negative, independent of the actual motion of the object.